Okay. Okay, welcome back. Today we are in the second half of our class. Okay, we are going to cover kinetic of particles. Okay, so if you still remember, to recap the equation that you have learned in Newton's second law, which is uh, force equal to mass times acceleration. And also, if you have many forces, you get to have summation of force equal to mass times acceleration. Okay. So in our previous class, we have covered example 2.1. So today, we're going to cover example 2.2. Okay. So in example 2.2, we look at the problem statement there. Okay, you are given the block, okay, of mass 30 kilo. Okay, initially at rest. Okay, so it will pull up along the ramp. Okay, pull up along the ramp with the value of 390 force P with the angle of inverse tangent 5 over 12. Okay, and this angle for the ramp, the angle of the ramp is theta. Okay, theta which is inverse tangent 3 over 4. Okay, and you also here you can see you have between the two surface. Okay, you have the surface contact which with the rough, which is rough with coefficient of friction is given there with the value of mu. Okay, so in this problem, what you need to solve is first of all, the question asks you to find, okay, between block and ram. It's smooth. It's smooth. Means no friction. Okay, smooth. So we neglect friction for case A. For case B, we have the surface roughness 0.2. Okay, so we need to consider the put into consideration the calculation of mu. Okay, which is friction. So find immediately after the force is applied the acceleration of the block. What will be the acceleration of the block? Okay, what will be the displacement of the block and the velocity? Yeah, okay. Okay. What will be the displacement of the block and the velocity when t equal to 5 seconds? Okay, this is part A. Okay, we do this first, right? Okay, we need to choose what kind of coordinate system. Okay, since we have done in our previous class, okay, what kind of coordinate system we are going to choose xy coordinates, okay, as our reference. Okay, so we have different normal and tangent later, for example, cylindrical coordinate. So this one we choose, we have x and y coordinate system as our reference. Okay, so the block only move in x direction. Yeah. Okay, so you can solve this problem in a normal way, or you can choose your own reference. Okay, so in this case we choose our reference like this. Look at here, look at here. So we take our datum from here. Okay, we take here. So this one, this is x, this is y. Okay, so we take this as x axis, this is y axis. Okay, and then if you work from there, it will be much easier. Okay, the easiest one. Only this part we need to use different what we call to write in terms of sine and cosine. Okay. Okay. So the free body diagram of this one. Okay. So if you draw the further free body diagram of this one, if you take x and y as a data, so can anybody share your thought on how to draw the diagram for this one? I use different color. You can, which color you want to use? Blue, green. Uh, okay. Okay. So first thing, you need to find, you draw what? You draw the body weight, right? Body weight of this one. So this is body weight. Okay. So the body weight. So if you have y here in this direction, so the angle is theta here. Okay. This is body weight. Body weight equal to mg. Okay. Right? Okay. How about this one? Since you know that this one is given, beta is inverse tangent of 5/12. So 5/12. Okay. So we're going to have here, if we have Pythagoras, if we have 5, 12, 13, right?
30.
So same thing with this one. We have 3, 4, 5. The hypotenuse is 5. So this one, the hypotenuse is 13. Okay. So you have here, you can draw the diagram. So you have, based on the information given, the 12, 5, 30. Okay. Right. So this RAM you have given 3, 4, 3, 4, 5. Okay. Right. Okay. And then what else? You have body weight, you have force, you know, you have the angle of this ram of the force and the ram of the surface. Another thing we need to write down also is
Normal.
normal force. Okay, remember, normal force is perpendicular to the surface. Okay, this is normal force. Okay, so this is the important part of on how to solve this type of problem. Okay, so we take note that over here block has only motion in x direction. Okay, so we don't have the motion in y direction. It's only in x direction. Okay, only in this x direction. Okay, therefore we have ax and ay equal to 0. But this is the thing that is important. All right. So we use Newton's second law here. Okay. And then we do the summation of force in x direction equal to max. Okay. Based on this figure. Okay. Based on this figure, you're going to have p cosine beta. Okay. P cosine beta minus mg sine theta. Okay. Minus mg. This direction, this direction. This direction. Equal to ma, which is here. Follow the same direction. Okay. So you solve for a. Okay. Solve for a. You're going to get in this form. So as I said last time, do not cepat-cepat or you want to substitute the value. No, do not substitute yet. because that one you substitute later. So you settle this one and then you put in this form and then now you substitute the rate. Okay, which is 390. Okay, given in the problem 390 Newton. Okay, 390 Newton divided by M, which is 30 kilogram. Okay, 30 kilogram. Cosine beta, which is 12 over 13, and then sine beta, okay, which is 3 over 5 sine beta. So we're going to get this value 6.11 meter per second. Okay, this is the kinetic part. Okay, that's why again and again I urge you, encourage you to revise all of this lah. Okay, how to, because this is you have learned in trigonometry. Okay, long time ago. Okay, so need to refresh. Like in dynamic or in static, want to use this a lot. Okay, and then we proceed to kinematic part. So when we solve this kind of problem, do not isolate yourself. Oh, this is kinetic. Or because this is like a building block. You need to use your previous knowledge, what you have learned in kinematics. Okay, so this is constant acceleration. You can find the value of x and v. Okay, simply you substitute the value here, vt, x dot, v dot 0, and then half at square. Okay, at a, the value of a you have obtained 6.1, and then after how many seconds given in the problem? 3 seconds. Okay, so what will be after 3 seconds? The displacement of 27.5 meter. Dia bayang 27.5 meter. How far it will go? Okay, 27.5 meter. Okay, and then the velocity is, we substitute the value here, v plus acceleration time, so 18.3. Okay, so that is the first part, no friction. Okay, no friction. And then we proceed for part B. For part B, same thing, but you have to add the frictional force there, right? So if you have frictional force there, meaning you have the direction of force. If this P move to the right, so we have a frictional force there, right? Which is mu time N, right? Mu times normal. Okay. So we proceed for part B. Okay. We proceed for part B. For this case, you have to put symmetry of force in x and y direction there. Based on, we are focusing here. Okay, this one. Again, same free body diagram, but with additional information here, which is frictional force. Okay, we know that F equal to mu n. Okay, so you do the summation of force for x and y. Okay, for x and y. Okay, so for y, we have n minus mg cosine theta plus 3 sin beta. We write in terms of n, and then for summation of force in x direction, okay, you write down this equation and then you solve for a, and then you substitute the value. Okay, then you get the value is acceleration 5.54. Okay, the tadi apa? What you get? Acceleration 6.11. Logic? Is it logical or not? No friction 6.11. With friction we have 5.54. Logic lah, right? Sebab ada
Yes,
friction.
logic.
So it would slow
Logic,
down.
sir.
It's logical lah. Tapi kalau you dapat value with friction higher than friction limit, salah. Yeah. Jadi kena, the ticking part should be there. So with friction you have 5.54. Sometimes you get the answer 5.54 kilometer. You tak logik lah. You kena check lah. Kena check. Tak boleh silap. And then you proceed by substitute using the kinematic of it, you can find the value of x. Okay, so 24.9, lower than the previous one, and then the velocity is 16.62 and lower than without friction. Okay, all right, clear this one? Any question?
Clear.
Yes, sir.
Okay, sir.
All right. Okay, we proceed to do this example. Okay, in our first half of our class, we have spent our time to cover the dependent motion kinematics, kinematic of particle. Okay, now we're going to use how we can use kinetics, Newton's second law, to solve this kind of problem. Yeah, all right. Mesh pulley system consists of two blocks A and B. Okay, so block A and block B. Block A 10 kilo. Block B 6 kilo. Okay. The surface contact between block B smooth. Okay. And then neglect the mass of the cable. Okay. Cable and the pulley are also the friction of the pulley. So no friction, frictionless lah. Friction. So you need to find the acceleration of each block, the tension of the cable. Okay, if the system is released from rest, find acceleration of each block and the tension of the cable. For part B, what is the velocity of the block after it has displaced 0.8 meter, and what would be the time? Okay. Okay. This is something interesting. So these are the theory that we're going to use to solve this problem. Number one, kinematic of particles. You know, the length of the cable constant. And then you're going to use Newton's second law. Summation of force equal to mass times acceleration. Okay, these are the assumption or the information given when you say smooth surface, meaning no friction. And then what else? Mass of the cable and the pulley, you can neglect. Friction in the pulley also neglect. There is no air resistance. Okay. But in the era of nanotechnology, okay, nanotechnology or MEMS, macro electrical mechanical system, you cannot ignore air, okay? Because air, the micro level, when you design at micro level, um, some student, the researcher, they have a problem. They say, why their motor cannot rotate? Cannot rotate. Yeah, because the motor is so small, so small. So micro motor, micro motor or nano motor. So they have to rotate or do the experiment in vacuum situation, okay, so that the air will not stop the motor from rotating. Yeah? So you need to aware of that also. Yeah. But for the case, normal case, the one that we design, is the, the normal size, big size. So air resistant we can neglect. Okay. Okay, these are the information that you need to, the ones you get the problem, you need to look at the diagram to find out what are the theory that you're going to use and what are the assumptions. Okay. We proceed. I want to make this smaller. Okay. Okay. Look at the diagram. The diagram, we have, we draw the datum here. Okay. XA, XB. Okay. So from here going down, this is Y direction. Okay. So from here to your right, this is X. So we have X, YA, and XB. Okay. Then what else do we have? You cut these two. Ada scissor, cut. So how many? So we have 2Y over here, right? So 2Y, you can write the kinematic relation 2YA plus XB equal to constant. So this is the kinematic relation of this one, the first part. Okay. And then now we look at the second part, another theory which is kinematics. Okay, kinematics. This block, okay, this block, this block you have a body weight, you have normal, okay, normal B, and then what else? You have the kinetics diagram, which is MA MB times extension of B. Okay. And then for this one, okay, for this one you don't have any surface over here. It's hanging. It's hanging. So we're going to have again, this is weight of A, and then the kinetic part, which is MA. Okay, okay. This is MA. This is MB AB. This is MA AA. Okay. So for the string over here, okay, for kinematic part, you also have, you can see, because we have to relate with Newton's second law, we're going to have the tension of the string, okay, tension of the string, T1, and then another T over here, okay, alright, so ada lagi tertinggal. We have a body weight, we have normal, You have body weight, and then you have the tension of the string. Okay, and then we have the acceleration, mass time acceleration for both. Okay, once you obtain all of this in the direction of it, okay, you show it there, and then now you start to set up the equation for kinematics and kinetics. Okay, so for kinematics, once you obtain this one, you can get the acceleration of it. Okay, differentiate with respect to time, right? Twice you get acceleration, which is you get acceleration of b equal to minus 2a. Okay? Okay, how about this one for kinetics for block A and block B? So for block A, you do the summation of force in y direction equal to MAY. So just simply we look at block A, and then you can see over there W A minus 2T equal to MA. Okay, so you get equation 2. And then for block B, you're going to get summation of force in x direction to the right is positive. Okay, so you have minus P there equal to MB times AA. So you get P equal to MA acceleration of P. Okay, and then you start to substitute all of this to find acceleration. Okay, by having this information. Okay, so you get acceleration of A, you get 2.885 meter per second square, which direction, which is going down. Acceleration of B, you get minus 5.70, meaning because you start by do the assumption that acceleration mass times acceleration moving to the right, so you get the answer is minus, so meaning acceleration of A is pointing towards to your left hand side. Okay, so acceleration of B equal to 5.77 meter per second. So we have done part A, now part B. So for part B, so part B, you have obtained T equal to 34.6. Okay, from question 3. Okay, this one. This is the tension of the rope. And part C, simply you are using constant acceleration equation. Okay, you use V square equal to V dot plus 2A delta, which is 0.8. Okay, so you get 2.15. And then what will be the time? So 2.15 equal to 0 plus 2.885, which is 0.75 seconds. Okay. All right. Any comment? So meaning to solve this kind of problem, you need to combine your previous knowledge, which is you need to have to know kinetics of particle. Okay, write that equation. Okay, and then length of the cable is constant, and then you apply kinetic of Newton's second law. Okay. All right. Are you with me or not? Are you
Yes, bro.
okay?
Yes, bro.
Yes, bro.
Yes.
Oh, okay. Yeah. Very good. Very good. More very good. Like uh, I want to go through one more, which is related to the motor problem. Motor problem. Where is motor problem? Let me see. So many motor. Oh yeah, we have motor problem. Okay, 2.9. 2.9. All right. Okay. We have a motor here. Bundle of roof tile B. Mass 100 kilo. Transport to the roof through a motor-driven lift consisting a platform A of the mass 30 kilo. Okay, with the angle theta 12/5. The system is initially at rest. So the motor suddenly apply constant tension magnitude 1800 Newton. Frictional force also is given between the bundle and the platform. Okay, mu S.2, mu T.1. Soalan, find whether the bundle will slide or not. Cuba, sama macam first question last time lah. Whether the bundle will move or not, it will slide or not. Okay. And then what will be the corresponding reaction at the interface between bundle and the platform. Okay. So for this type of problem, you need to use Newton's second law. Okay. Alright. Okay. So read this problem again one more time so that you can try to understand. Okay, I give you 1 or 2 minutes to read the question again. We analyze it. Understanding the problem is very important. Okay, first one, bundle will slide or not? Okay, so we assume first thing is block B does not sleep on block A. So if it doesn't sleep on block A, meaning they are considered as a single unit. Okay, so we consider as one body. Okay, as one unit. So A and B together, consider it as together. Okay, so they move together as single unit, thus they will have same acceleration. Okay, same acceleration. Consider as one body. All right. So acceleration of AX equal to A equal to acceleration of A equal to acceleration of B. Okay. Apa? Datum. They put a datum from the diagram here. When they consider it as one body, okay, they consider it as one body. So they choose a datum. This is theta. So we have normal for normal there. This is normal. Okay. And then the datum. So we choose a datum X. Okay. This is X and this is Y. Okay. And then now start to have body weight there. Okay. This is body weight. So combine both weight A and B together. Okay. And then this is tension of the motor. Okay. Which is 1800. And then what else? Mass time acceleration. So you put both MA and MB times acceleration. So weight A, weight B, then you have normal force, and then you take datum. This one to the right is positive, and Y this way is positive. Okay, this is X. Okay. And then after you have obtained this one, we can start using Newton's second law, which is summation of force in x direction and summation of force for block, for the block. Okay. So you get here summation of force E minus this one you resolve into sine and cosine, you get sine theta equal to MA plus MB times acceleration. So you solve for A, you get T minus MA plus MB times G sine theta. Okay, so you get 1800 minus 30 plus 100. Okay, 130 times 9.81, and then the RAM. So you get 12 over 30, and then you divide by 130. Okay, 130. And then you get 4.79 meter per second. Okay, so for block B, block B, so block B is F equal to MA. Okay, this is X and Y. So you get FB equal to MA cosine theta, you get 55. And then you can check, if FB max greater than FB. So you get Fy over here is 427. Okay. This one we have this kind of situation we have analyzed before. Okay. So you get FB maximum is 85. Okay. FB 55. Therefore, there is no slipping between the bundle and the platform. Okay. Therefore, FB equal to 55.3 and N equal to 427. Okay. We can proceed this one by asking this question. What will happen if mu is 0.12? Okay, 0.12. Or when the tension is 25. So you substitute the value. Okay, substitute the value and then you make a comment. Okay. So I think I'm going to stop here. I hope you can go through this again. Okay, try to understand. Okay, understand. Try to do on your own. Okay, try to solve without looking at the solution. Whether you can get the answer or not. Yeah. And this Wednesday, as I mentioned, we're going to have our first quiz. First quiz. So going to be one problem, and then we have three parts: part A, part B, and part C. Okay, very similar to your exam, ODL exam. We have part A, B, and C. Okay, the concept, the calculation, and assessment. Okay? So the coverage is on the kinematic, kinematic of particle. Okay guys, I think that's all for today. Good luck. Selamat berbuka puasa. Stay safe. Okay. I'll
Okay,
see
bro.
you next
Okay, bro.